Hello. Today we are going to be starting chapter 2, so you should have a new set of notes in front of you that make sure you put them in your binder. No, this does not mean you can get rid of your chapter 1 notes. Just keep both in your chapter, or in your folder, but keep chapter 2 closer to the front since we'll be using that more than the chapter 1. Okay? So our learning intention today says that we will learn to understand integers. So chapter 2, as you can see in the top right hand corner, is all about integers and rational numbers. So that's what we're going to be going over. So there's a definition that I'll go over, but really I just want you to be thinking about positive and negative numbers and zero. That's what we're going to be dealing with in this chapter. So this first question says, Sal recorded the outdoor temperature as -4 degrees Fahrenheit at 7:30 a.m. At noon, it was 22 degrees Fahrenheit. Sal said the temperature changed by 18 degrees because 22 minus 4 equals 18. Is Sal right or wrong? Explain. And then what was the total temperature change? So I want you to think about this. Okay, if you want to, you can pause the video to come up with your own reasoning, and then you can play the video to see if you got it correct. But think about, is Sal right or wrong? Did the temperature change by 18 degrees? All right, so is Sal right or wrong? Sal is wrong. Okay. And I want you to think, okay, so if what didn't change by 18 degrees, how much did it change by? So if we created just a little number line, and I'm going to put 0 in the middle. Okay, this is going to be a wonky number line, but it's what I'm going to do. And we're going to put -4 here. So that's what the temperature started at. So it started at less than 0, which is why it's to the left of 0. And then at noon, it was 22 degrees. So at noon, it was all the way over here at 22 degrees. And so it couldn't have changed 18 degrees because from 0 to 22, that's 22. Okay, but we also have this 4 right here. So to go from -4 to 0, that's 4. So we need to combine 22 plus 4 to figure out how much it changed altogether. Because to go from -4 to 0, that's 4 degrees. And then from 0 degrees to 22 degrees, that's 22 degrees. So we have to add both of those numbers up. And so that would be 26 degrees altogether. From -4 to 22, it changed 26 degrees. So we would say it changed 26 degrees. And that would be our answer over here, sorry. So Sal is wrong because it changed 26 degrees. So anytime you're confused today, I want you to think of a number line. And you can even draw one out, kind of like I did. It doesn't have to be a super fancy one, just one that helps you understand where our numbers are at. Or look back at this number line that we have right here, or there's the number line in your trapper, or in your folder. So this number line right here, it has the negative integers on the left of 0. Remember, 0 is right in the middle. And we have our positive integers to the right of 0. So always remember, negative numbers are on the left, positive numbers are on the right. And then it says 0 is neither positive nor negative, and the opposite of 0 is 0. So you can't say you have -$0. Okay? You just have $0. It's not positive nor negative, it's just 0. So the first thing we're going to write down for our vocab is opposites. Opposites are numbers that are located on opposite sides of 0 and are the same distance from 0. So if we look up at our number line, we have +6 and -6. They are opposites because they're on opposite sides of 0 and they're the same distance from 0. So even though one's negative and one's positive, they're opposites because they're both 6 units from 0. And they're in opposite directions. Okay? So then +10 and -10 would be opposites. +1 and -1 would be opposites. It's any numbers that are located on opposite sides of 0 and are the same distance from 0. So then integers is our next vocab word. And integers include counting numbers, their opposites, and zeros. Or in zero, sorry. So our counting numbers are 1, 2, 3, 4, and so on. And their opposites, well, the opposite of 1 is -1. The opposite of 2 is -2. The opposite of -3 is -3. The opposite of 4 is -4, and so on. And then we have 0. So really, any number that you would see on a normal number line in a classroom, those are integers. So on this first example, we need to fill in the missing integers. So we can see here, -1 and 1. Well, what should be exactly between them? It should be 0. Okay, 0 is the middle of the number line, and it's what separates our positive and our negative numbers. So then to the right, I can tell that it's going up by ones. So this would be 1, 2, 3, 4. It would be a +4. Now when you write a positive number, you do not need to have a plus sign in front. Okay, I just know that that's a +4. But if we were to write a negative number like a -4, which would go here, you have to have that negative sign. If you didn't and you just put a 4, that would be wrong because +4 and -4 are different. So next, this one says, Riley recorded the temperature for 5 days in January. Monday was -5 degrees. Tuesday was -2 degrees. Wednesday was +4 degrees. Thursday was -3 degrees. And Friday was 1 degree. It says, write the temperatures from least to greatest. So I want you to think of a number line. Okay, remember, our 0 would go in the middle, and then all of our negative numbers go on the left. So we want the farthest number from 0 to go on the left. So that would be -5. That one is the farthest from 0 that we have. And then, so we're just looking at our negative numbers. We have -2 and -3 left. Well, which one is farther from 0? It would be -3, so that one comes next. And then our last negative number is -2. And then we're going to pretend that there's a 0 there because now we're moving on to our positive numbers. And so it would go 1 and then 4. So notice, so we go -5, -3, -2, +1, and then +4. A tricky part is, because a lot of people, when they look at the negatives, they say, well, 2 is smaller than 5. Why is that more to the right? But you have to think of it in terms of being closest to 0. When you're in negative, you'd rather be in debt -$2, or you'd rather be in debt $2 than $5 because it's closer to 0. You're closer to getting out of debt. Okay? So that's why it flip-flops a little bit. So now it's asking which day was the coldest. Well, the coldest would be the -5 degrees. So Monday was the coldest. And then the warmest would be the 4-degree day, which was Wednesday. So those would be our answers for those. Go ahead and flip your page over. Now, example 2, we're going to be using integers to represent quantities. So it says, integers describe many real-world situations, including altitude, elevation, depth, temperature, and electrical charges. 0 represents a specific value in each situation. So we want to look over at our picture. Now, we have our water, our sea level, right here. Then we have an airplane and a whale. So it says, what integer represents sea level? Well, the sea level is where the sea meets the air. And so the integer would be 0. So the integer that represents sea level is 0. And some of you may hear that a lot, or have heard it before, like 100 feet below sea level or 100 feet above sea level. Different things like that. And those all, just remember, sea level represents 0. So then what integer represents the airplane? Well, here's our airplane. And so it's at about 10,000 feet. I'm assuming these are feet. I'm not quite sure since it's not labeled. But so our integer would be a positive 10,000. You can put that positive sign if you want, but you do not need it. So I'm just going to put 10,000. And then what integer represents the whale? Well, there's the whale, and it's at about negative 10,000. And you have to have your negative sign. All right. On these last examples, so you're going to write the integer that represents each situation. So remember, anytime it asks for integer, that's our counting numbers, their opposites, and 0. So any number you would see on a number line is an integer. So don't get confused by that. So if we have a $10 debt, that means we owe someone or something $10. So we do not have that money. We're in debt, so that's a negative 10. Where on the flip side, if we had a profit of $10, that would mean we gained that, so it would be a positive. But when you're in debt, you are in the negatives. So the next one says 6 degrees below 0. So if we're below 0, thinking of temperature, that's a negative, so this would be negative 6. Now this one says the opposite of 3. Well, remember our definition for opposite was numbers that are located on opposite sides of 0 and are the same distance from 0. So the opposite of 3 would be a negative 3 because it's the same distance from 0, but it's on opposite sides of 0. Then an elevation of 1,250 feet, you may hear that like in the mountains. If you're at an elevation or up in the air, like on a plane, that's where you would hear elevation. So an elevation of 1,250 feet means we're above ground, and so that would be positive 1,250. Then we have 12 feet underwater. So if we're underwater, that means we're below sea level, so that's going to be a negative, so that'd be negative 12. And then if we're 4 feet above sea level, we're above, that's our key word, so that would be a positive 4. All right. Our learning intention said, today we learned how to write integers to represent situations so we can do what? Well, let's think about some of the examples it gave us, okay? It can help us understand debt. It can help us understand temperature. It can help us understand elevation, sea level. So it can help us understand all of those different things that we'll use in the real world. Okay, you are going to see integers all the time. Okay, we see integers in sports every day. For football, if you have a penalty, that's negative 10, negative 15 yards. Okay? So we use positives and negatives all the time. So I'm going to write, so we learned how to write integers to represent situations so we can understand money. And so we can understand football penalties. So we can understand temperature. And so on. There are so many different things we could write down for this. And so how will I know I've learned it? We'll say when we can teach someone else. All right. And that is the end of the notes, and you are good to go.